Jim, as you heard from him, he's a professor in Biological and Agricultural Engineering Department at the University of Florida, expert in climate change, and he has a USAID-funded grant called AgMIP, which is looking at a variety of modeling schemes to predict the impact of climate change. So with that.
Thanks. Yeah, thank you again. This AgMIP is a bit different from the example that Ajit talked to you about. And in a sense, we're not a funding mechanism per se, but there are a lot of implications for obtaining funding through the association with and participation in AgMIP. And I'll try to explain that a little bit in terms of our history. But to start out with, AgMIP is Agricultural Model Intercomparison and Improvement Project. Cynthia Rosenzweig at Columbia University and NASA Goddard Institute for Space Studies is the principal investigator. I am a co-principal investigator along with Jerry Hatfield, an agronomist in Iowa State University at USDA, and John Antle, an economist. And John is at Oregon State University. And you can see even by the people involved in leading this initiative, truly interdisciplinary in nature. And I think that's one of the characteristics that we will see, or we should aim for, as we look for solutions to these really complex problems. And we started out in 2010 with our first global annual workshop, and AgMIP has grown ever since then. It's really a global community of agricultural scientists, and I'll tell you a little bit about what we do later on. But what our aim was to start with was to significantly advance the scientific capabilities for addressing complex agriculture and food security issues at global and regional scales in a changing climate. And why AgMIP? Well, we've heard many of the reasons this morning, and I've also said in my talk this morning that agricultural models, crop models, soil models, pest and disease models, economic models, livestock models are all used to help us integrate our understanding and try to find ways to create solutions for that. And the problem with this, though, is that if different models are used for the same studies, you may come up with different answers. And you can't compare results across the world if you use a model that we developed in Florida or one that was developed in Germany or in China or other places. And this is true not only for production, but also the economics and global food trade. It turns out there were about 10 different models that were developed worldwide that are producing different answers. I showed that result a little bit this morning in terms of the different prices that were projected under climate change. So we were aiming for a long-term process to try to help guide and gain resources in order to improve the capabilities for doing these kinds of analysis. I mean, this isn't going to provide all the solutions that are there, but we certainly need good agricultural system models in order to address these problems. So part of the motivation for this, when we first got together and were talking about this in 2008, was this whole model comparison, and noting the fact that in the climate modeling world, multiple models are used. And this is just a schematic on the bottom of showing something that's very common in my part of the world, and that's hurricanes. And multiple models are actually used to project the pathways of hurricanes or to project the weather conditions over the next week or two or climate in the future. And the things that the climate modelers have found is that if you use multiple models, you actually get better predictions by using the median or the mean from these models than you will from any particular model. There's just that much uncertainty in creating models for these complex issues. So one of the questions we had was, this hasn't been done for agriculture. Would it be the same in agriculture? So as I said, it's really a global community of science. We had seed funding for 2 years from USDA that allowed us to form the project, and then we also got funding from UK Aid or DFID in the UK, a fairly large amount of money for doing work in sub-Saharan Africa and South Asia, and also from USAID. But it goes beyond that, and I'll explain that in a few moments. In creating this, we did it by forming teams, and we formed teams by disciplinary teams in a way. We have a climate team, for example, a crop modeling team, and an economics team. And then we also have, you see the work groups there. We realized that this isn't sufficient, but it's all that we felt like we could start with. And so we also have a water resources modeling team, and in fact, Rafa Munoz Carpena is co-leader of that. He's an ASABE member. Many of you may know him. And a livestock and grasslands team being co-led out of France and Australia, also with ILRI at one of the CG centers. And we have a new pest and disease modeling group that is just forming, and a soils modeling group that's actually being led by Bruno Basso at Michigan State University. And what we're doing there then is we're applying these models, trying to improve them, compare them, and as a community applying them for assessing climate change impacts and adaptation at regional and global scales, and also for helping to build capacity, in particularly in developing countries, for doing that. And there are about 31 different initiatives. Many of these have their own specific funding outside of what we have in this sort of core funding that we have. And so this community allows teams to form, and with support from different funding agencies, perform different types of activities. Some of the activities are actually unfunded. It's just that all the researchers realize that it's to their advantage to use some of their own resources to participate in this global community. For example, one of the first efforts was led by Sentola Singh and Frank Ivert from Bond University. Sentola is from University of Florida. And the question there was if we use 27 different wheat models. And I had no idea that there were 27 wheat models in the world, but there are, developed all over the world. What will the results be if we use one model versus another one? And will the median or mean actually be better than any particular model? This is a paper that was just published in Nature Climate Change, showing the X's show 4 locations around the world where we had yields of, in the Netherlands, of about 8 tons, in Argentina about 6 tons, India about 4 tons, and in Australia about 2 tons. So a wide range of production environments there. And each one of these 27 models were run without knowing anything about what the yields were in these studies. They had weather data and soil data and management information, and that's all they had in order to run these. And the large horizontal bars across there show the range of model results. So we see quite a range of results from each one of these models at each one of the locations. But you can also see the median is represented by the vertical line in each one of these horizontal bars. And in every case, the median was very close to the observed yields without any knowledge of what was happening or anything, but no calibration or any adjustments at all. When the yield results and production results were given to the modelers, the lower category, the lower horizontal bars, box and whisker plots showed that improvement was possible if they were able to make adjustments in the model based on the particular varieties that are being grown in these different locations. But we found that to be quite remarkable. A similar result has been found by the maize modelers. There's 18 maize or corn models around the world that have been intercompared like this, and also for rice models. We're working on sugarcane and other crops now, but this has so far proved to be very interesting and very helpful. So the median reproduces observed yields better than any particular model, regardless of where the model was developed. And if you are able to have data to calibrate the models, it improves it. But as I showed in my talk this morning, there are uncertainties, particularly in the interactions between water temperature and CO2, that definitely need improving. And so all of these teams now are working toward improving their models. So that's sort of the crop modeling story. I presented some results from the economic modelers today, this morning, and there were actually 10 economic modeling groups around the world that obtained separate funding to do this comparison. And they're now into phase 2, and they have funding to continue this work. In one case, they're actually working with USDA for a U.S. economic impact assessment, but also doing some work globally as well. This slide just shows the work that we're having to do to harmonize the databases. This is sort of an IT story. We have IT team members that are working on providing solutions that will allow us to use multiple crop models, multiple livestock models from different databases for producing these kind of results, and even harmonizing the databases for that. Of course, there's a lot of interest in open source data these days, and we're really promoting that as a part of our goals as well. So we've created now a global gridded crop modeling platform that allows you to plug in different models and run them for national or global studies on a worldwide basis. This is some of the results that's just been published in PNAS, the Proceedings of National Academies in the U.S. I showed this slide this morning, but the work here is continuing now to compare the multiple results on a global basis with the different databases that are available in the different countries, like in the U.S. for the USDA, FAO data, and so forth. We're also performing model integrated assessments, and this is the money that we got from the UK aid, and we funded actually 10 teams, 5 in Sub-Saharan Africa and 5 in South Asia. So the story behind that is that, yes, we are helping to fund, particularly in developing countries, efforts to bring them up to speed and make them have access to the same technologies and capabilities that we do, and this has been very successful. We had funding until this October, and we just learned that UK Aid is going to give us an extension to work for 2 more years with additional funding to work and try to work these results up through the policy process in the different countries. And this involved the crop, livestock, and economic modeling at every one of the countries that were involved. Very much a transdisciplinary effort. So now we're moving to a new global structure, and one of the things that I should point out too, Ajit mentioned the USAID funding. Well, we've put in a bid for a new USAID innovation lab on sustainable intensification. I know that Michigan State also did, and Texas A&M, and so there's several universities that put in bids for this. And as a part of that, there's one on appropriate scale mechanization that will be a major part of this sustainable intensification effort. And this is one that I think ASABE really needs to pay attention to and look for the kinds of technology and mechanization that will help increase the productivity in developing countries. And in addition to that mechanization piece, there will be other more management-oriented funding that we will provide to developing countries again if we're funded, and of course whoever is funded for that will do the same. But that's not for sure yet, but stay tuned. I mean, one of us will get that bid, and that would be an opportunity, I think, for a lot of people here in ASAB to capitalize on that, and in other countries. So in our new global program structure, USDA has agreed to support AgMIP on a continuing basis and be the home agency of AgMIP in the future. And so they actually received $2.4 million to support, I think, 4 laboratories for for AgMIP activities, and so we're working directly with USDA. USDA will also be the agency that will form memoranda of understanding with other countries, and we already have in process a memorandum of understanding with Brazil. Brazil is creating AgMIP Brazil, and so they're following this same pattern there, and they will have funding for researchers in Brazil to do this kind of modeling work, but also look for solutions as a part of the effort. And also with China, we're pretty far along already with China to create a group there, and in Korea, Pakistan, and Peru, and then there are other countries that are working toward this as well. So it really is a community of science. It's something that just caught on, that all the disciplines really jumped on this quickly, whether they had immediate funding or not, and now many of them are getting support. So this is expanding the AgMIP global community of science, and we're broadening the goal. Originally we looked only at climate change, but now we're looking at climate variability and extreme events, and also looking at more at sustainable intensification for increasing productivity in a sustainable way for food security. And we have a steering council that we are reconstituting now that is global in nature, people all over the world, high-level people that includes public and private sector folks. The Gates Foundation has funded a small effort for looking at next generation of agricultural models and decision support systems. They are very much interested in using models and decision support systems to try to improve the policy process and also help them decide on investments in research for different technologies. What is an independent evaluation of the benefits of particular technologies and where that might be useful. So continuing funding from DFID, from USAID, from Gates Foundation, USDA, and some from industry as well. And so I would encourage you to look at the agmip.org website, and we have our results there, and also it doesn't cost anything to join, and you might find a community there within AgMIP that would be very active in the kinds of things that you're doing, and they could very well use some input from agriculture and biological engineering. I really believe that, and I hope that we'll get more of that as we move forward. So thank you again.